All right, so we're looking at the notes from section 1.5, which is on midpoints, segment bisectors, and angle bisectors. There are a few definitions here that you'll see that you need to memorize. There are 3 of them total: midpoint, segment bisector, and angle bisector. Of course, those are the ones with little stars next to them. So if you're highlighting them or using colored pencils or whatever in some way, denote that those 3 must be memorized word for word. All right, so we're going to look at some definitions first and the midpoint formula, and then on the back of the page you'll find the 4 examples that we're going to be doing. All right, so let's start with the definition of midpoint. Definition of midpoint is a point that divides or bisects a segment into 2 congruent segments. So we start with, in the diagram of a midpoint, we start with a segment. We're going to call it AB. Oh, that's not straight at all. Let's try that again. It's a little better. And we have point M, its midpoint. Now, it says that it has to divide it into 2 congruent parts, which we would typically say would mean that it lies in the middle, or that it evenly splits it into 2 equal parts. The parts are segment AM and segment MB. Now, in a diagram, we'll see that they are congruent by marking little tick marks on each one. That is not something you can assume from a diagram. You have to be either given it in word form, M is the midpoint of segment AB, or it has to be marked in the diagram. Never assume that something is a midpoint. Now beyond that, once we see that it's a midpoint, then we can make a statement relating these 2 segments. So in this case, segment AM is congruent to segment MB. 2 parts are congruent if we know it's a midpoint. All right, second definition we need to look at is that of a segment bisector. Segment bisector is a segment, line, ray, or plane that intersects a segment at its midpoint. Notice that we've got several options here: a segment, a line, a ray, or a plane, and we'll talk about what all of that means in just a second. But the important part is that it intersects the segment at the midpoint. So here again, we've got a segment, call it AB again. And its midpoint is going to be identified. We're going to call it M. That's fairly typical. It doesn't have to be M, but that's what we're going to call it. Because it's a midpoint, we know that we have 2 congruent parts, just like what we have up above. Now in this case, a segment bisector has to be one of these 4 objects: a segment, a line, a ray, or a plane that intersects the segment at its midpoint, meaning it has to cross through line M. Now it doesn't matter if I draw a segment through line M, or if I draw a line through line M, or point M, or a ray from point M, but in some form I have some object that passes through, passes through point M. Like so. I'm going to draw a line in this case. So this line L is the bisector of segment AB. And keep in mind, it is not the one and only bisector. It's one of many. We could draw infinitely many lines passing through point M. Likewise, there are infinitely many segments passing through point M. But some object, a segment, a line, a ray, or a plane, that passes through that midpoint. So the object passing through the midpoint is known as the segment bisector. The midpoint is that specific point M. All right, so you've got some relationship then here between these 2 definitions and how they relate to segments. The next 2 we're going to look at have to do with angles. You'll notice that this third one, adjacent angles, is not one that you have to have memorized. It is one that we have to understand because it's going to come up, that phrase adjacent angles is going to come up again not only in the definition of angle bisector that we'll do today, but in some other angles pairs that we're going to be talking about later in the book and throughout the year. So adjacent angles are important to understand just what they are. We're going to start off with the formal definition: 2 angles that have a common vertex and side but have no interior points in common. Now if you remember what a vertex is, the vertex of an angle is the point where the 2 rays begin. It's that shared initial point. It's what some people might call the corner of the angle. And the side of an angle is a ray, one of the rays coming out of the vertex. So I need two angles that share a vertex and share a side. So what that's going to look like in terms of a diagram is two angles that are right next to one another. They share this one side right down here. Keep in mind, those two angles do not have to be congruent. It simply means that this middle ray has to be in the interior of this larger angle. So we're going to name some points here. Let's call this A, D, C, and B. And you have to be very careful about which ones are adjacent versus which ones are not. So we're going to identify some adjacent angles first, and then we'll look at some that are not adjacent, and you'll see how it works and how they are different. Okay, so our adjacent angles, I'm going to start with angle ABD, ADB, and angle CDB. Okay, so ADB, shade the interior of ADB for a second. If I shade the interior of that first angle that I listed, we see that all of its interior points are here. So that's this one in this pale purpley pink. Then we're going to use a green and shade angle CDB's interior. CDB would go to there. Now you'll notice that those two colors don't overlap. They're separate. They have that shared boundary. Ray DB is still a shared boundary between them, but there are no points on the diagram that are both purple and green. That's what makes them adjacent. Now let's look at an example of what non-adjacent angles are. So let's take off some coloring here. Take off the green, take off the purple. And let's look at non-adjacent angles. I'm going to start with the same angle ADB. And this time I want to use as its other pair ADC. Adjacent angles are going to come in pairs. So now let's color and see what happens. So ADB is that same angle we started with before, now in a blue. And now we'll look at ADC and we'll color that one in pink. Okay, so ADC goes from here all the way over there. Now you'll notice what happened. There is some set of points that are both colored blue and colored pink. That's what keeps them from being adjacent. They still share a common ray. They still share ray DA. They still share a common vertex at D, but they can have no interior points in common. So adjacent angles will be neighbors to one another. They will be next to one another. They will share a side, but none of the interior points in one will also be interior points in the other. They will be two separate colors, if you want to think of it in that frame of mind. They will never overlap. Non-adjacent angles are going to break one or both of the parts of that definition. They have to share a common side. They have to share a common vertex, but they cannot have interior points in common. So you can see the difference there based on the way we colored them. Okay, so adjacent angles, angles that are right next to each other but don't overlap one another. It's much like your yard and your neighbor's yard. They don't cross each other. There's a boundary between them. That's what adjacent angles are. Share a common side, share a common vertex, but don't overlap. They don't have any interior points in common. So now we talk about an angle bisector then. An angle bisector is a ray that divides an angle into two adjacent angles, two neighboring angles, that are congruent. So we start with an angle. It doesn't matter whether that angle is acute, right, or obtuse. But I'm going to sketch an angle over here. And I will call it ABC. Now it says an angle bisector is a ray. It's going to start at the same vertex B, and it's going to divide that obtuse angle that I have drawn there into two angles that are congruent. Now, if you think about what that means, I've got to divide this measure of angle ABC into 2 equal portions. So that ray is going to have to divide it evenly. Now, I don't expect your sketches to be perfect, but they should at least look close. So what should happen then is that this angle ABD would be congruent to angle DBC. That I get 2 congruent portions. Remember how we mark congruent parts of angles with the little arcs. So in this case, BD, ray BD, bisects angle ABC. Divides it into 2 congruent parts. And our 2 congruent parts, remember how we name congruent angles? Angle ABD is congruent to angle CBD. There again, that's not something you can look at in a diagram and assume. It's something you have to know. It has to be stated, it has to be given, it has to be in the diagram. You cannot tell it by just looking at it. Because an 89-degree angle and a 91-degree angle are going to look really similar, but they are not congruent. All right, so those take care of our 4 definitions then. We've got the 2 relating segments and then the 2 relating angles. Now let's look at the midpoint formula. Now, keep in mind that midpoints only exist on segments. You don't have a midpoint of an angle. So everything that we're talking about here in this formula deals with a segment, something with 2 endpoints. Okay, our formal definition that we're going to be using. If A, point x1, y1, and B, x2, y2, are 2 points in a coordinate plane, then the midpoint of segment AB has coordinate m, remember we use m to denote our midpoint, of x sub m, y sub m, where x sub m equals x sub 1 plus x sub 2 all divided by 2, and y sub m equals y sub 1 plus y sub 2 all divided by 2. Now think about what that means. What do we call it when we take 2 numbers and add them together and then divide by 2? It's simply an average. So in this case, we average x1 and x sub 1 and x sub 2, and that gives us our midpoint value for x. And here we average y sub 1 and y sub 2. And that gives us our y value for our midpoint. So these formulas that we have here simply give us the values that fill in up here in our point. Your answer should be a point. You're finding a midpoint. You're finding an end point. It is a point. It should still be in parentheses with a comma in between. Don't just list random numbers. That's not the same. All right, so on the back, we have 4 examples that we're going to be looking at, and you'll see that the first 2 are very similar. On the first one, find the midpoint of segment DE with endpoints D, 3, 5, and E, negative 4, 0. So here we're asked to find the midpoint. As I look at number 2, the midpoint of segment XY is M, 3, negative 4. One endpoint is Y, negative 3, negative 1. Find the coordinates of the other endpoint. So in one we're finding a midpoint, and the other we're finding an endpoint. It doesn't matter which one you're finding, the same formulas are going to get used because we're still dealing with the midpoint of a segment. So in that regard, we start with our formulas. I want you to get in the habit here in the beginning of writing your formula down before you fill anything into it. That's going to help stick that formula into your memory so that you don't have to actually spend time trying to memorize it. It'll just kind of be there. Okay, so we have our 2 different parts of the formula, the one for x and the one part for y. And then those will become a point at the end. Okay, so we're going to let D be x sub 1, y sub 1, and E be x sub 2, y sub 2. And we'll fill those values in accordingly. So x sub m, I know that that doesn't fill in because I'm not given a midpoint value, equals x sub 1, which is 3, plus x sub 2, which is negative 4, all divided by 2. Simplify your numerator first and get negative 1 over 2. And we know that doesn't divide out nicely to a whole number, so we'll just leave it as a fraction. You could write it as a decimal if you wanted to, but there's not really any purpose in doing that. Okay, so now we go to the y's. There again, don't know the y value for the midpoint. We're trying to find the midpoint. So y sub 1 is 5 plus y sub 2, 0, all divided by 2. Simplify your numerator, 5 over 2. And there again, it doesn't divide out to be a whole number, so we'll just leave it in fraction form. So our midpoint in this case, and you can call it m, you can call it whatever, it doesn't really matter, is x coordinate first, -1/2, comma, 5/2. Always put the x value first, y value second. Okay, now on this next one, the only thing that changes is that instead of being given both endpoints, we're given one endpoint and we're given a midpoint. So since this is a midpoint, we're going to label these as x sub m and y sub m, which means they're going to fill in on the left side of each of those formulas. The one endpoint we're given, we're going to call x sub 1 and y sub 1. So in this case, we're finding x sub 2, y sub 2, the other end. Okay, so we write down our formulas. And we're going to start filling in. Okay, so substitute in our values. X sub m is 3 equals x sub 1, -3, plus x sub 2, we don't know that one, so leave that as is, all divided by 2. Now, in order to solve that, to get x sub 2 by itself, we're going to have to first start by multiplying by 2 on both sides to undo this division by 2. So those are going to cancel each other out. And we'll be left with 6 equals -3 plus x sub 2. Add the 3 to both sides. 6 plus 3 becomes 9 equals x sub 2. And we're going to take a similar course of action for the y's. Y sub m is -4 equals y sub 1, -1, plus y sub 2, which is unknown, all divided by 2. Follow the same plan as before, multiply by 2 to get those to cancel. What we do to one side, we have to do to the other. So in this case, we get -8 equals -1 plus y sub 2. Add the 1 to both sides. -7 equals y sub 2. Now remember, your answer is a point. So in this case, the x value first, 9. Y value second, -7. And that is the answer to the problem. Okay, so that tells you how we're going to work with midpoints of segments. Now the next two look at angle bisectors and how those work. I would advise you to get in the habit of reading one sentence at a time and to draw a diagram, label a diagram, do something with each sentence as you come to it. Don't try to just absorb it all and figure it all out in the end. So in this first sentence for number 3, ray JK bisects angle HJL. So I'm going to start by drawing angle HJL. Because it is a sketch, don't worry about whether it should be acute, right, or obtuse. Just get it onto paper. H, J, and L. And remember, when you name your angle, you're following along the sides in order. I could have started down here at the bottom and made this H, then J, then L. That wouldn't have mattered. Okay, so we have our angle. Now we need a ray that bisects it. Now remember, a bisector goes right through the middle, giving us two congruent parts. And it says that should be called JK. So we've got J, this will be K. Now we've got two congruent parts. Go ahead and mark those accordingly. Put your little arcs in place. So that all comes from that first sentence. Go to the next sentence. Given that the measure of angle HJL, that's this big angle here. Given that the measure of angle HJL equals 42 degrees. So we'll label that on our diagram. What are the measures of angles HJK and KJL? Now you have to kind of keep in mind, you know that these two parts are congruent, and we know they have to total 42. So I'm going to take 42 and divide it by 2 to get 21. So the measure of angle HJK equals 21 degrees. Don't forget your little m. The measure of angle KJL equals 21 degrees. And that's how we're going to write notationally, how we're going to write measures of an angle. Remember the little m out front. And don't forget your degree symbol. Okay, so that's angle 3, or number 3. 4, last one. In the diagram, ray MO bisects angle LMN. Okay, so we see the ray MO drawn into angle LMN. Since it bisects it, we know that means we've got two congruent parts. The measures of the two congruent angles are 3x minus 20 and x plus 10. Now, because they are congruent, it doesn't matter which one is labeled as which. So I'm going to say this one is 3x minus 20, and this one is x plus 10. Now, if they're congruent, think about what that means. If two angles are congruent, then they have the same measure. Or another way to say that, then their measures are equal. So one angle is equal to the other. In this case, 3x minus 20 is equal to x plus 10 because it has been bisected. Because the angles are congruent, their measures are equal. Okay, so we solve that for x. Subtract x on both sides. Add 20 to both sides. And divide by 2 on both sides. So I get x equals 15. Now the nice thing about these, you should be able to check them. If you fill it back in over here, if we substitute into our two places, there and there, we ought to get the same values. So in this first one, if I fill in 15, I get 3 times 15, which is 45. 45 minus 20 is 25 degrees. I substitute into the other one, x plus 10. 15 plus 10 becomes 25 degrees as well, which tells me that my answer is correct. If I got different answers, then I know that I've made a mistake, either in my substitution when I was checking my answer, or whenever I was working the problem out, or it might even be as far back as how I set up the equation. If you find a mistake, check all of those things again. Don't just erase everything and try to start over. Check it first. You might find out that you just made some silly error. All right, so that takes care of midpoints, segment bisectors, and angle bisectors.